Hello and welcome to the Tech Think Tank. I'm Saptasha, and in today's video, we're going to dive into the world of Kubernetes. If you're interested in container orchestration and deployment automation, then you're in the right place. Kubernetes is a powerful open-source platform that allows you to manage and scale your containerized applications with ease. In this video, we'll cover everything you need to know about Kubernetes, including its architecture, key features, and benefits. So sit back, relax, and let's get started.
What is Kubernetes?
Brilliant question, Sam. Kubernetes is an open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications. It was originally developed by Google, and now it's maintained by the Cloud Native Computing Foundation, CNCF. Kubernetes provides a way to manage and coordinate containerized applications across a cluster of hosts. It allows developers to deploy their applications to a cluster of machines, and Kubernetes will take care of the details of managing and scaling the containers that make up the application. Some of the key features of Kubernetes include: 1. Automatic scaling. Kubernetes can automatically scale the number of containers based on demand. 2. Service discovery and load balancing. Kubernetes provides a way to discover and route traffic to services running in containers. 3. Self-healing. Kubernetes can automatically detect and replace failed containers. 4. Rolling updates. Kubernetes can update containers with new versions without downtime. 5. Configuration management. Kubernetes provides a way to manage application configuration across multiple environments. Kubernetes has become a popular choice for deploying and managing cloud-native applications, particularly those based on microservices architectures. It provides a platform for building and deploying scalable, fault-tolerant, and highly available applications in a cloud-native environment.
What is the use of Kubernetes?
As you already know, Jenny, Kubernetes is an open-source platform that is used for managing containerized applications. Its primary function is to automate the deployment, scaling, and management of containerized applications. It provides a highly flexible and scalable infrastructure for container orchestration that can be used to deploy and manage applications across a variety of platforms, including on-premises, public, and private clouds. Kubernetes is widely used for managing microservices architectures, where applications are broken down into small, independent services that can be deployed, scaled, and managed separately. It helps ensure these services are highly available, reliable, and scalable. If you want to know more about microservices, click the pop-up banner now or the link in the description. Some of the key benefits of using Kubernetes include: 1. Automation. Kubernetes automates many of the tasks associated with deploying and managing containerized applications, reducing the burden on developers and operators. 2. Scalability. Kubernetes makes it easy to scale applications up or down based on demand, ensuring that they can handle heavy traffic loads without downtime. 3. Portability. Kubernetes provides a consistent platform for deploying and managing applications across a variety of infrastructure environments, including on-premises data centers and public clouds. 4. Resilience. Kubernetes provides robust mechanisms for ensuring that applications are highly available and can recover quickly from failures. Overall, Kubernetes is an essential tool for organizations that are looking to build and manage modern, containerized applications at scale.
Let's now discuss Kubernetes key features and how to implement these key features if you are using Kubernetes.
Kubernetes provides several mechanisms for the automatic scaling of containerized applications based on demand. The most commonly used mechanism for automatic scaling in Kubernetes is Horizontal Pod Autoscaler, HPA. HPA automatically scales the number of replicas of a pod, which is a group of one or more containers, based on the CPU utilization or custom metrics of the pod. When the CPU utilization or custom metrics of a pod exceed a certain threshold, HPA automatically increases the number of replicas of the pod to handle the increased load. Similarly, when the CPU utilization or custom metrics decrease, HPA automatically reduces the number of replicas of the pod to save resources.
HPA works by periodically querying the metrics of the pods and comparing them with the target metrics specified by the user. If the actual metrics exceed the target metrics, HPA increases the number of replicas of the pod. HPA uses Kubernetes built-in scaling APIs to add or remove replicas of the pod. In addition to HPA, Kubernetes provides other mechanisms for automatic scaling, such as cluster autoscaler, which automatically scales the number of nodes in a cluster based on demand, and vertical pod autoscaler, which automatically adjusts the CPU and memory requests of the containers based on their usage patterns.
To implement automatic scaling in Kubernetes, you can use the horizontal pod autoscaler feature. Here are the high-level steps to implement automatic scaling with HPA. 1. Deploy your application to Kubernetes using a deployment or replica set. A deployment or replica set defines the desired state of the application and manages the creation and deletion of pods. 2. Enable metrics collection for your application by deploying a metrics server or Prometheus server to your Kubernetes cluster. These servers collect and expose metrics about your application, such as CPU utilization and memory usage. 3. Define the scaling policy for your application by creating an HPA object in Kubernetes. The HPA object specifies the minimum and maximum number of replicas for your application, as well as the target CPU utilization or custom metrics for scaling. 4. Monitor your application and observe how it behaves under different loads. You can use load testing tools or real-world traffic to simulate load on your application. 5. Analyze the metrics collected by the metrics server or Prometheus server to determine if your application needs to be scaled up or down. You can use tools like kubectl top to view the CPU and memory utilization of your pods. 6. If your application needs to be scaled up or down, the HPA controller in Kubernetes automatically adjusts the number of replicas based on the scaling policy you defined. Overall, implementing automatic scaling with HPA in Kubernetes involves configuring your application, defining the scaling policy, and monitoring the metrics to ensure that your application is running efficiently and effectively.
Kubernetes provides built-in service discovery and load balancing mechanisms to enable communication between the different components of a distributed application running in containers. These mechanisms are implemented through two primary Kubernetes objects, services and endpoints. A Kubernetes service is an abstraction that provides a stable IP address and DNS name for a set of pods. Services allow other components of the application to communicate with the pods through a stable endpoint, even if the pods are constantly being created or destroyed. Services also provide load balancing by distributing incoming traffic evenly among the pods that make up the service. Endpoints are dynamically created objects that represent the addresses of the pods that are part of a service. Kubernetes automatically creates and updates endpoints objects as pods are added to or removed from the service. Endpoints allow the service to forward traffic to the correct pod and port. When a client sends a request to a Kubernetes service, the service uses a load balancer to distribute the traffic among the pods that make up the service. The load balancer selects a pod based on a predefined algorithm, such as round-robin or IP hashing, and forwards the request to the selected pod. In addition to load balancing, Kubernetes services provide a way to perform service discovery. Applications can discover the endpoints of other services by querying the Kubernetes DNS service or using environment variables that Kubernetes creates for each service. Overall, Kubernetes provides a flexible and powerful system for service discovery and load balancing that allows developers to easily create and manage complex distributed applications.
To implement service discovery and load balancing in Kubernetes, you can follow these high-level steps. 1. Create a deployment or replica set that manages the pods for your application. Each pod should have a unique name and a label that identifies it as a member of the application.
2. Create a service object that exposes your application to the network. The service object should use a selector to specify which pods should be included in the service.
3. Choose a service type for your service object. The most common types are cluster IP, node port, and load balancer. The cluster IP type creates an internal IP address for the service, which can be used within the Kubernetes cluster. The node port type exposes the service on a specific port on each node in the cluster. The load balancer type creates an external IP address for the service and configures a load balancer to distribute traffic to the pods.
4. Use the DNS name of the service object to communicate with your application. Kubernetes automatically creates a DNS record for the service object, which can be used to discover the endpoints of the pods.
5. Test the service object by sending requests to the DNS name or IP address of the service. Kubernetes automatically load balances incoming traffic to the pods that are part of the service.
6. Monitor the service object and adjust the scaling and configuration as necessary. You can use tools like kubectl to view the status of the service and the pods that are part of the service. Overall, implementing service discovery and load balancing in Kubernetes involves creating a service object that exposes your application to the network and uses a load balancer to distribute traffic to the pods. By using a service object, you can provide a stable endpoint for your application that can be accessed by other components of the application or by external clients.
Kubernetes is designed to provide self-healing capabilities to ensure that your application remains available and responsive in the face of failures or issues. The self-healing capabilities of Kubernetes are implemented through several key features, including 1. Replication and rescheduling. Kubernetes automatically manages the creation and deletion of containers or pods to ensure that the desired number of replicas are running at all times. If a container or pod fails, Kubernetes automatically reschedules it on another node to maintain the desired number of replicas.
2. Health checks. Kubernetes provides a built-in health checking mechanism to ensure that containers or pods are running and healthy. You can define liveness and readiness probes to check the health of your containers or pods. If a container or pod fails a health check, Kubernetes automatically restarts or reschedules it.
3. Rolling updates. Kubernetes supports rolling updates for your application, which allow you to update your application without downtime. During a rolling update, Kubernetes gradually replaces old pods with new ones, ensuring that your application remains available throughout the update process.
4. Stateful sets. Stateful sets are a Kubernetes feature that enables the deployment of stateful applications, such as databases or queues, in a self-healing manner. Stateful sets provide guarantees about the identity and ordering of pods, enabling the recovery of persistent state in the event of pod failures or rescheduling. Overall, Kubernetes provides a robust set of self-healing features that enable your application to automatically recover from failures or issues. By leveraging these features, you can build highly available and resilient applications that can continue to serve your users even in the face of failures.
To implement self-healing in Kubernetes, let's follow these high-level steps. 1. Define a Kubernetes deployment or stateful set object that manages the pods for your application. Each pod should have a unique name and a label that identifies it as a member of the application. 2. Configure health checks for your containers or pods. Kubernetes provides two types of health checks, liveness probes and readiness probes. Liveness probes check whether your container or pod is running, while readiness probes check whether your container or pod is ready to receive traffic. 3. Define a replication controller that specifies the desired number of replicas for your deployment or stateful set. Kubernetes automatically manages the creation and deletion of containers or pods to maintain the desired number of replicas. 4. Configure the rescheduling behavior for your deployment or stateful set. Kubernetes provides several rescheduling options, including pod disruption budgets and pod anti-affinity, which can help ensure that your application remains available and resilient in the face of failures. 5. Use Kubernetes rolling updates to update your application without downtime. During a rolling update, Kubernetes gradually replaces old pods with new ones, ensuring that your application remains available throughout the update process. 6. Monitor the health of your application and adjust the scaling and configuration as necessary. You can use tools like kubectl to view the status of your pods and the health of your containers. Overall, implementing self-healing in Kubernetes involves defining a deployment or stateful set object that manages the pods for your application, configuring health checks, and defining a replication controller that specifies the desired number of replicas. By leveraging these features, you can ensure that your application remains available and resilient in the face of failures or issues.
Kubernetes provides rolling updates as a built-in feature that allows you to update your application without downtime. Rolling updates are a gradual and controlled process that replaces old pods with new ones, ensuring that your application remains available throughout the update process.
Here's how rolling updates work in Kubernetes.
1. Define a Kubernetes deployment or replica set object that manages the pods for your application. Each pod should have a unique name and a label that identifies it as a member of the application.
2. Create a new version of your container image or configuration. You can use Kubernetes config maps or secrets to manage your application configuration separately from your container images.
3. Update the deployment or replica set with the new version of your container image or configuration. Kubernetes automatically creates new pods with the updated version and gradually replaces old pods with new ones.
4. Monitor the status of the rolling update using kubectl. You can use the kubectl rollout status command to view the progress of the update.
5. Use Kubernetes rollback to revert to a previous version of your application if necessary. Kubernetes maintains a revision history of your deployment or replica set, allowing you to easily roll back to a previous version in the event of issues or failures.
Overall, rolling updates in Kubernetes provide a safe and reliable way to update your application without downtime. By gradually replacing old pods with new ones, Kubernetes ensures that your application remains available and responsive throughout the update process.
Now let's discuss how to implement rolling updates in Kubernetes.
1. Define a Kubernetes deployment or replica set object that manages the pods for your application. Each pod should have a unique name and a label that identifies it as a member of the application.
2. Create a new version of your container image or configuration. You can use Kubernetes config maps or secrets to manage your application configuration separately from your container images.
3. Update the deployment or replica set with the new version of your container image or configuration. You can use kubectl to update the container image or configuration of your deployment or replica set. Use the flashing syntax as an example command. kubectl set image deployment / deployment name container name equals new image.
4. Monitor the status of the rolling update using kubectl. You can use the kubectl rollout status command to view the progress of the update. Use the flashing syntax as an example command. kubectl rollout status deployment or deployment name.
5. Use Kubernetes rollback to revert to a previous version of your application if necessary. If issues arise during the rolling update, you can use kubectl to roll back to a previous revision of your deployment or replica set. Use the flashing syntax as an example command. kubectl rollout undo deployment / deployment name.
Overall, implementing rolling updates in Kubernetes involves updating the container image or configuration of your deployment or replica set and monitoring the status of the rolling update using kubectl. By leveraging these features, you can update your application without downtime and easily roll back to a previous version in the event of issues or failures.
Kubernetes provides several ways to manage configuration for your applications, including 1. Kubernetes config maps. Config maps allow you to manage configuration data as key value pairs or as configuration files. You can create config maps from literal values, files, or directories, and then use them in your application pods as environment variables or mounted volumes. 2. Kubernetes secrets. Secrets are similar to config maps, but they are designed to store sensitive information, such as passwords or API keys. You can use secrets to manage secrets as key value pairs or as files, and then use them in your application pods as environment variables or mounted volumes. 3. Kubernetes resource configurations. Kubernetes resource configurations are YML files that define the desired state of your application. You can use resource configurations to manage container images, environment variables, volume mounts, and other aspects of your application. 4. Kubernetes operators. Operators are Kubernetes extensions that allow you to automate the management of complex applications or services. Operators can handle tasks such as scaling, backup and restore, and rolling updates. Overall, Kubernetes provides several powerful tools for managing configuration data for your applications. By using config maps, secrets, resource configurations, and operators, you can manage application configuration data separately from your application code and ensure that your applications are configured correctly and consistently. To implement configuration management in Kubernetes, you can follow these steps. 1. Define your application configuration data. This can include environment variables, configuration files, and other configuration data that your application requires. 2. Create a Kubernetes config map or secret object to store your configuration data. You can create config maps or secrets using YAML files or by using the kubectl command line tool. 3. Mount the config map or secret into your application pods as an environment variable or volume. You can define a volume mount in your Kubernetes deployment or stateful set object or set the environment variables in your pod spec. 4. Update your application to read its configuration data from the mounted volume or environment variables. 5. Use Kubernetes resource configurations to manage your application's container images, environment variables, and other aspects of its configuration. Resource configurations are YAML files that define the desired state of your application. Overall, implementing configuration management in Kubernetes involves creating config maps or secrets to store your application configuration data, mounting them into your application pods, and updating your application to read its configuration data from the mounted volume or environment variables. By using Kubernetes resource configurations, you can manage your application's configuration data separately from your application code and ensure that your application is configured correctly and consistently. And there you have it, a comprehensive overview of Kubernetes. We hope you found this video informative and useful. If you have any questions or comments, please leave them in the comments section below, and we'll do our best to answer them. Don't forget to subscribe to our channel for more tech-related content, and hit the bell icon to stay updated on our latest videos. Thank you for watching the Tech Think Tank, and we'll see you in the next one.